this video, I'm going to introduce a submarine into our aquarium. So, as a reminder of sort of how we got started in lab, we're going to go to the CSC 212 assignments, open that project, open the source main Java, open this package inside of it. Then if you double click on aquarium, you'll be in the same place as me over here. I've removed the starter fish from my aquarium, so I just have the ocean. And if I go to run that, you'll see that a blue screen is going to pop up. And nothing is happening in this aquarium right now. So I'm going to close that. And then we're going to go over here to this package, and we're going to right click, go to new, and then choose class. And I'm going to call this class Submarine. So Submarine is a nice empty class here. And the three things I'm going to build into the submarine at first are just a position and a color, much like the fish we worked on in lab. And of course, Eclipse doesn't know where color comes from. Color cannot be resolved into a type. That's a new one. Try again. Import. I don't know why I couldn't find it that time, but these are my three variables so far, and so we need a constructor to go with those variables. So the constructor is called Submarine, and it's going to take an int x, an int y, and a color. This will be a little clearer if I call these start x, start y, start color. And this dot x equals start x, this dot y equals start y, and this dot color equals start color. And so now that we've sort of created things, I'm going to make this package thing smaller so I use all my screen space. And we're going to want a draw method, much like the fish draw method. And that's going to take a graphics 2D world, or win. And Eclipse can find it this time, which is good, so we don't have to come up here and type the import statement. So in the draw method, let's just do something right off the bat, which is to set the color, this dot color, and fill oval x minus 4, y minus 4, 8, and 8. And that should give us a colored circle. And that way we know something has happened. If we go back to aquarium now, we need to create a submarine. And we can call this anything we like. I'm going to call it Ringo because I want a yellow submarine. And I'm going to put it right in the center of my aquarium and make it yellow. And so instead of clicking the normal run button, I'm going to click this debug run button. It's going to ask me to save like it normally does, and it's going to pop up. And I click the debug button because I forgot to call ringo.draw. So if I come into the draw method of aquarium without closing my debugging run, I'm going to be able to call ringo.draw. I'm going to be able to edit the methods in my program without restarting. So you can see that that little yellow circle popped up. And this sort of compile and substitute is something that Eclipse gives you. And I'm going to use a lot while I'm figuring out how to be artistic over here. So to draw a submarine, I kind of want it longer than it is tall. So I'm going to change this to something like minus 20 and make it 40 wide. When I save, I can see that happen right away. I think we want a little bit taller than that, so I'm going to change this to like minus 10, this one 20. Yeah, so the oval we're drawing here is 20 tall and 40 wide. And so this is 40 wide here, and this is 20 tall. Okay, so let's keep drawing this. So it'd be nice to have a little rectangle that looked like the top of the submarine. And so I've got my cheat sheet here, fiddled with this a little bit. Y minus 15, the width is going to be 14, and the height is going to be 30. Well, 30 would be my guess from this Y parameter. And that sort of draws this rectangle here. I kind of only want it sticking up at the top, so I'm going to change this to 10. And that gives me what I'm looking for. So that's kind of my submarine here. To fiddle with for loops, we're going to actually try and draw a window. So we're going to do a for loop. Int w, we're going to go from -2 to 3. Well, let's just go to 10. 0 to 10 for right now. And then you'll see why I came up with those numbers. And we're going to set our color. And we're going to draw little circles on top of it that look like windows. And so I'm going to G fill oval one more time. And then we're going to do X plus W times 6. And we're going to do it at Y, and the width of these things is going to be 4. The height of these things is going to be 4. Oh, and we've got a string of dots going on here. So we actually want is Y minus 2, because we want it to be centered. And that shifts them up just a little bit. And we also want to have these start over to the left. So instead of starting at 0, let's have it start at like 3. And then we'll have it only go to like 3. Is that right? That's right. That looks more like what we want. And so we'd also kind of like a border. So I'm going to set the color to black, and I'm going to copy this fill oval call that we have here. And I'm going to call it draw oval instead. And that should draw like an outline for us. Cool. So that's our submarine so far. The next thing we're going to do is we're going to just show one more drawing command. So we're going to set color to black in case it's not. And we're going to draw a little periscope. And so we're going to do G dot draw line. Oh, completely went away. Draw line. Yeah. And then we're going to start it at X. We're going to go Y minus 15 or so. I don't know exactly where it's going to come off the top. And then it's going to go straight up. So the X doesn't change on this line. And then we're going to go to Y minus 30. We save that. Oh, there's a little like pixel there, so we may want it to start at Y minus 16. Cool. And let's draw another line going to the left from there. So we can use X, Y minus 30. So we're going to start at this point, and then we're going to the left of it. So X minus 6, and then Y minus 30 here. And so having this sort of debug run open, I clicked on this a long time ago instead of this, means that as I'm fiddling with these drawing parameters, I can see them show up immediately. And that's very helpful. Okay, so we've drawn our submarine now. What we want to do here is we want to build a destination in, much like we did with the fish. It's going to have a slightly different kind of movement because we expect the submarine to maybe go up and down quicker than it goes left and right, and that's something we can handle. So I'm going to introduce a couple new variables here. I'm going to introduce a destination, and I'm going to introduce a speed. And I'm going to go here and go to this destination X equals, I'm going to pick something. A submarine has to do a lot of work to go up and down, so its X speed is going to be faster than its Y speed. Oops. That direction. Oh, this time when I saved, it says hot code replace failed, And really what it's telling me is Eclipse can't generate new members of your classes on the fly because your submarine already exists. To like go through and find your submarines that exist and add these fields, it needs to just restart. It's given up. So we're going to choose restart. It's going to think about it for a second, and then it's going to pop up the window again. So if you ever see that window, you can usually click restart. And so I'm going to create a sort of swim method here, but I'm going to call it navigate because submarines don't swim. And I'm going to call it from draw. The very first thing that happens in draw is that we call navigate. And again, Eclipse doesn't know how to add a method to a class that already exists, so we're going to tell it it's okay for it to restart. Let's give it up here. And so I've given a hint on Piazza about how to make things move, and that hint is to think about the guessing game. So I'm going to do that style of movement here. So we're going to do if this.x is less than this.destx, else if this.x is greater than this.destx, and then we're going to have an else here, where we've made it. And so in this situation, we want to actually move the x. Since it's less than the destination, we want to add the x speed to it. Speed x. And here is going to be the opposite case. We're going to subtract the speed from it. And if you don't remember, this.x minus equals is shorthand for this.x equals this.x minus this.speedx. This version lets you write this version a lot quicker. So we're going to stick with that. And so if I save this, we should see our submarine take off. Oh no, our submarine is shaking back and forth. What's going on? So the x speed here is 4, which is bigger than 1, so it never actually gets quite to destination. What it's doing is it's hopping between 102 on the right and 98 on the left. And then it realizes it's on the left side, and then it tries to go right, and it's doing this very, very quickly. So what we actually need to do is make, if we have a speed involved, is we need to think about the speed. Oops, I put that on the wrong side. Look at me. So we basically want to say, like, is this next step going to take us in the direction of the destination or not? And here we want a minus. If we do that, we'll see that it stops moving. But we're not totally done here because we haven't quite made it. We've just made it within speed. So when we've made it, we can always just do this. And then I'll just like move it over by whatever's left. So I put a comment to that effect, why this statement is here. Okay, and this, we've made it. We now want to start looking at the y movement. And the y movement is going to look a lot like the x movement. So I've sort of decided that I want the submarine to like move in one direction and then the next direction separately. So it's going to move in a very sort of square robotic way. And to accomplish that, we need to put our y movement inside this else. Like when we've already made all of our x movement, then we can think about y. So I'm going to sort of copy my ideas from this, from the x movement that we have working. And then we need an else, our time, this.y equals this.dest.y. So we're going to copy those ideas. When we save this, we're going to see our submarine move up. Okay, how do we test this? Well, let's give it a new destination. We could change the destination up here, tell it to go kind of back where it came from, but that's not going to do anything because the constructor only runs once. So what we might want to do is take this statement just temporarily and put it inside of our draw method. We save that and Eclipse puts the code in. It runs draw all the time, so it picks up the new destinations that we're writing here. So we'll make it go off screen. And you can see that it always does X movement first, which it's better at, and then it does Y movement to get to where it's going. Cool. So that's kind of the guts of our submarine here. It'd be kind of nice now is if it didn't draw the periscope, these black lines at the end, if it were moving. So if we were to comment these out, essentially it disappears. So that should be like the moving state of our submarine. So to make this happen, we need a Boolean moving. And this will be a lot like the fish facing left or right. And it's always good procedure to define what the starting point is for moving in the constructor. We know that it's going to get false by default by playing around with Java variables, but someone reading our code might not, and we shouldn't depend on them knowing that. And so here, I'm going to only draw these lines if this is moving. So that's going to make the lines disappear. And again, we've created a new variable on our class, on all of our objects, and Eclipse can't handle that. So it tells us it wants us to restart. And so by default, oops, we forgot to delete these destination lines, so it didn't move initially. Save, get rid of those for now. By default, it thinks it's moving. What we really need to do is update moving and navigate. So we could do, here it's moving, here it's moving, here it's moving, here it's moving, and here it's not moving. Okay, so we put a lot of moving equals true, so maybe the way we want to write this is instead like this. By default, we assume we're moving, then we can get rid of this, get rid of this, get rid of this, get rid of this, and then we can do moving equals false here. And let us actually restart it ourselves. So I'm going to click the stop button, and we'll start that debug up one more time. Oops. My if statement might be backwards, right? So I say if this is moving, draw the periscope. And what I really meant is if this is not moving. Okay, so let's stop and start it again. Make sure that works. Cool. So now when it's moving, when it has a destination, we get, when it's moving, it doesn't draw the periscope, and when it's not moving, it does. Cool. So we have this little class here, and it does a whole bunch of little behavior and looks and acts like a submarine. So now I'm going to introduce something kind of cool, which is that we can get where the user clicks their mouse and send the submarine toward it. And so on any subclass of GFX, so on Aquarium, we have the ability to say this dot process click. And this returns a new class we haven't talked about yet, which is called endpoint. We're going to call this maybe click, and you'll see why in a second. So if we just file save right here, this is what I've been doing to load in the code. Because we have a syntax error, Eclipse was going to ask us to confirm our perspective switch. Basically, there's an exception that was just thrown, which is a compilation exception. Eclipse puts like a little error in and lets you try and run. And we don't really want that. And it wants to ask if we want to debug this program. And no, we don't want to debug this program. We just want to fix it. We want to go back to editing. We want to say import endpoint. So that's a class I made. It came along with the drawing that you're using. And we want to say ringo.destx equals maybe click.x. and ringo.destY equals maybe click.y. So we're going to click this little play button again. It's the resume button. Yeah, this time we want to switch because something's happened. What has happened? And it's not even going to tell us. Okay, we're going to stop. We're going to go back to Java, and we're just going to run it normally. Scroll up here. Exception in thread main, Java lang null pointer exception. Oh, you know what has happened? When I wrote process click, it returns the position that the user clicked most recently, but it doesn't do that if the user hasn't even clicked yet. What it does is it returns that magical null value, which we talked about a little bit in class. So basically, we need to, oops, wrong direction. We need to check to see if the user's clicked. So we get the click object, but that click object might be null, and if it's not null, then we know where the user clicked. So let's save that. And let's close this broken aquarium, and let's start it up again. And now if we click here, Submarine's going to move toward our click. And we didn't have to write any loops for this because all we did was reach in and say, okay, your destination, the destination of our submarine Ringo, is where the user clicked. And that submarine takes its time. But you can see how you sort of can confuse it because you always just overwrite where it was going as soon as you click again. And because it does X first, you can sort of make it bounce back and forth. And that's the total of our submarine object here. The design of it should help you if you're still working on your fish. And talking about clicks a little bit and null a little bit and seeing some more for loops just gives you another example to work with. All right, that's going to be it for this video.